Hi everyone, welcome to the last part of doing some problems for finding the RS configuration of some of these different molecules. Now let's look at this brominated ring molecule. As always, let's try to find the stereocenter. I see one right over here. And we can infer from this that the hydrogen is going to be in the back. So let's first assign priority. The bromide, 1. Now which R group will get priority? This one will, because it hits the alkene first. And so let's rewrite this to better organize it. Bromide, hydrogen, R2. I'm going to name that R2 for second priority, and then R1 for first priority. And now let's reorganize that. So our first priority atom, which is bromine, goes along the plane. Right now it's facing towards us. So let's pretend that we're rotating that bond back so it goes along the plane with R1. Now what'll happen? Will be in the back, and R2 is in front. And now let's put our first priority atom on top. Be 1, 2, 3, 4. It's rotating that way, so it is going to be S configuration. Perfect. Next problem, we have this brominated pentene ring. Here is our stereocenter right here. Or is it a stereocenter? Though it does have 4 different substituents, because it is symmetrical, right over there, that carbon is actually not asymmetric, and so these two R groups are basically the same, and thus no stereocenter, and so there's no way in trying to figure out whether it's an R. Next, let's look at this alkene. Now it may seem tricky at first, but let's attack it as we would any other stereochemistry problem. So first, let's try to find the stereocenters, which is this carbon and this carbon. Let's first look at the lateral carbon right over here. So first, let's assign priority. Be 1, 2, 3, and then hydrogen in the back would get 4. So first, let's organize this. And this is going to be our configuration for the back carbon. Right? So this carbon right over here, it's going to be similar priority assignments. It'll be R1 first, R3 in the back, R2 in the front, and hydrogen facing out here. So hydrogen is basically up. So hydrogen is basically like that on that carbon. So let's try to find the configuration. So it is rotating this way because this R3 group is in the back. And so it's going to be reaching the hydrogen last. So that's why it's going in the S direction. So this is going to be the S configuration.